Okay, so in lesson 6, we are moving into compound inequalities. And we're going to look at 2 different compound inequalities. Inequalities that are joined by the word or, and then inequalities that are joined by the word and. So if we start with our or inequalities, this or means that the solution makes only one of the inequalities true. And graphs of these or inequalities are going to graph apart. So I've given you an example below. The or inequality is that x is less than or equal to -2 or x is greater than 3. So we take these 2 solutions and they're graphed on the same number line, and we use those same rules that we did in lesson 5 when we graph. So depending on the inequality sign is going to tell you if the dot's opened or closed, and then if it's less than, you're going to the left. If it's greater than, you're going to the right. And because this is an or, this is what I mean, that those arrows should be going in opposite directions. So they should be graphing apart. Okay? So we've got 2 quick examples here. When we have the inequalities joined by the word or, these are just 2 single inequalities that are just connected with this word. So all you're going to do to solve for x here is just solve each individual inequality and then graph those solutions on the same number line. So this first one, super simple here. We have 3x is less than 6. So all I would have to do to solve for the x is divide by the 3, which means x is going to be less than 2. Or, well, now I just come over to this second inequality and just solve it. So I'm going to divide by the 7 and get or x is greater than 5. So now that we have that solution, we're just going to graph both of those inequalities on the same number line. So I've got 2, 3, 4, 5. And then if I look at this inequality sign, I've got just less than, which tells me on 2, I'm going to have an open circle, and I'm going to shade to the left. And then I have or x is greater than 5. So since it's just greater than, I have an open circle and I shade to the right. Easy. All right, we're going to do one more. So number 2, I've got p plus 5 is greater than or equal to 10, or -2p minus 2 is greater than 8. So again, just solve each individual inequality. So for the first one, all I need to do is subtract the 5 so that I have p is greater than or equal to 5. And then, or, when I come over and solve the second inequality, first I will add 2 to remove that constant. So we get -2p is greater than 10. And then our coefficient, we're going to be dividing by a negative, which means we're going to do what with the inequality sign? Flip it. So I have p is less than -5. And now this makes sense, and if I were to rewrite it so that it was in order from least to greatest, it would be more like p is less than -5 or p is greater than or equal to 5. So even though at first it looked like we might be shading in the same direction, once we solved the second one, we had to flip that inequality sign. So these are still going to graph apart. So then when I come to graph it on the number line, I'm just going to do -5, 0, and 5. Keep it nice and easy. If you did all of it, that's okay. Then, since it's just p is less than -5, I've got that open circle on -5, and I'm shading to the left. Or p is greater than or equal to 5. So now that it's greater than or equal to on 5, I'm going to have this closed circle, and I'll shade to the right. Any questions on our or inequalities? Okay, then let's move into and inequalities. An and inequality is going to mean that those solutions are going to make both inequalities true. And when we have graphs of and inequalities, what you will notice here is that they're going to graph together. So what we are showing with these and inequalities are the solutions for x that would satisfy both of those inequalities. Okay? So I've given you an example of x is less or greater than or equal to -6 and less than or equal to 1. So -6 is this minimum value, 1 is this maximum value, and so we shade in between to show that anything in between those two values satisfies both. Now, because the solution to an and inequality falls between two different endpoints, we're going to frequently write this in a much more condensed form. So we won't actually use the word and. We will write it so that we start with our first endpoint, which is -6, that least value. So we would have -6, and we'd say that's less than or equal to x, right? Because over here it says x is greater than or equal to -6. So if we flip it around, -6 is less than or equal to x, and then we've got our second endpoint, which is the 1, but x is less than or equal to 1. So this condensed form is going to help us show that the x is going to be in between this minimum and maximum value. Those are the x values that will satisfy both of our inequalities. Okay? So now, if you look at the examples, we have 3 is less than or equal to 5x minus 2, which is less than or equal to 13. This is two different inequalities. So like this is an inequality and this is an inequality. So you could always break this up into those two inequalities and solve two at a time. Wait, you don't have to necessarily write this because I'm going to show you a quicker way. So you could break this into the two different inequalities and solve each like one at a time. Or since it's already in this condensed form, we are just going to work to get this x in the middle by itself, making sure whatever inverse operations we do to isolate the x in the middle, we have to do to both endpoints. Because if we split it into the two different inequalities that it actually is, we'd be having to perform that inverse to both endpoints. Does that make sense? Okay, so in the middle, if x is being multiplied by 5 and we're subtracting 2, then just like any other equation, we're going to undo that constant first. So we're going to add 2 to cancel it out, but we also need to make sure we add 2 to the 3 and to the 13. So that then we're going to have 5 is less than or equal to 5x, which is less than or equal to 15. And now all I have to do to get that x in the middle by itself is get rid of that coefficient. So I'll divide by 5. But again, make sure you do it to both endpoints so that we're just solving each inequality at the same time instead of two separate. Okay? So now 5 divided by 5 is 1. So 1 is less than or equal to x, which is less than or equal to 3. So then on our number line, I'm just going to do 1, 2, and 3. Keep it nice and easy. Both of these inequality signs have the or equal to, so that means on 1 and on 3, we're going to have a closed dot. And then we're going to shade together to show anything between 1 and 3 would satisfy both of these inequalities that we have in number 3. All right, one more practice of the and then we're done. So we've got -2 is less than 2 times x minus 6, which is less than or equal to 4. So there's actually two different things you could do first here. What do you all want to do first? Okay. So we'll go ahead and distribute the 2. So we've gotten rid of the parentheses in the middle. So this is negative 2 is less than 2x minus 12, which is less than or equal to 4. The other option would have been to divide by 2 and get rid of that and then only have the x minus 6 left in the middle. So now, again, working to get that x by itself, we're going to get rid of that 12 first. Just making sure you do it to both sides. If you guys make a mistake on these problems, it's because you forget to do it to both endpoints. Wow, I didn't even hear you walk in. Stealthy. All right, so negative 2 plus the 12 is going to give us 10. So now we have 10 is less than 2x, which is less than or equal to the 16. Then the last thing we do to get that x by itself is undo that coefficient. So we'll divide by that 2. Leaving us 10 divided by 2 is 5. So 5 is less than x, which is less than or equal to 8. Then we will move over to our number line. And again, I'm just going to do 5, 6, 7, and 8. When I go to graph this solution, make sure you're paying attention to the inequality signs. So since this is just less than, on 5, I have an open circle. And then since this is a less than or equal to, on 8, I'm going to have a closed dot, but still shading together, since it's that and inequality.
If the variable is a negative and you have to put aside, you put one of those.
Both. That was a really good question that Jake just asked. He said, if the coefficient is negative and I have to divide by a negative, you would need to flip both of the inequality signs to keep the final inequality true. Okay? All right.